Hello, we are Ilaria and Marco on behalf of Ratio Team, and today we are going to show you a very interesting case study developed in SAS Via, which can help to improve the accessibility in cities, right?
Right. This project aims to do something very important. Did you know that in Italy only 60% of public buildings are accessible to people with disabilities, and only 40% of schools? Although national and European regulations have long promoted universal accessibility, mapping and monitoring architectural barriers across public spaces remain a challenging mission, often performed with inspections and reports from citizens. As a result, the available information on the actual state of urban accessibility is often incomplete and inconsistent.
In this context, computer vision technologies offer a concrete opportunity to innovate the way barriers are detected and managed. These models can detect objects, in this case steps, stairs, ramps, and grab bars, with extreme precision in thousands of photos, which can be acquired in multiple ways. This could be a way to assess the accessibility of an entire city, spotting in less time the critical zones where the public administration needs to design targeted intervention.
The training images were taken from a public repository in Zenodo, built supposedly for barrier detection. The training set contains the position of the objects in an XML file. This information is the base of the training procedure. We loaded the images and annotations directly into SAS Via using SWOT library, which allows to use cast functionalities from Python Jupyter Notebook. Then the data was cleaned and converted into the Pascal VOC format, a standard used for object detection. In Via, using a combination of cast actions and DLPy utilities, we parsed the XML files, created the detection tables, and then split the dataset into training and testing sets. This pre-processing pipeline ensures that every image is standardized in size and structure, preparing the data for model training while keeping the entire process centralized within the SAS environment.
Let's see how the computer vision model has been implemented in SAS Via, leveraging the power of the CAS server. There are several ways to build and train image detection models. For this use case, we used a tiny YOLO V2 model, implemented through DLPy, SAS deep learning package that integrates seamlessly with the CAS server. The model was trained directly in the Via Hub, using the object detection tables created. We defined the anchor boxes, optimized the parameters with an Adam optimizer, and trained the model for multiple epochs. Even without GPU resources, Via allowed us to run the training efficiently in a distributed environment, demonstrated that a complete computer vision workflow can be executed end-to-end within SAS.
The model progressively improved during training, a good result for a small dataset and CPU-based training. These results confirm that SAS Via can effectively handle complex deep learning models. Moreover, we also decided to train a second model using the YOLO architecture implemented in Python, leveraging open source frameworks. Thanks to SAS Via's flexibility, we could easily integrate this external model into our Via workflow, importing the predictions, promoting them to cast tables, and visualizing them in SAS Visual Analytics. This demonstrates how Via can act as a bridge between open-source machine learning and enterprise-grade analytics, allowing teams to combine the best of both worlds seamlessly.
To make the process more user-friendly, we implemented a prototype of an interactive interface to upload the images using SAS Studio HTML integration with custom tasks. After the job is triggered, a report of the barriers found by images and geographical information is created, to be later displayed in Visual Analytics. The final dataset contains information about whether each image includes an architectural barrier, such as stair or steps, and whether a ramp or a grab bar is present. And images results are even more impressive. Here you can see some examples of the model output. bounding boxes around detected obstacles and ramps, each labeled and classified automatically.
A summary of the findings is finally displayed in SAS Visual Analytics. The map shows the coordinates of the pictures taken. Clicking on each point, we can see the image. This is achieved with the Data-Driven Content tool, which allows to embed HTML code and display images targeted by SAS Visual Analytics visualizations. There are filters on the right to select a specific district or an architectural element. We also have other statistics showing a pie chart with the numbers of barriers detected and the bar chart for obstacles by district. Finally, we have a line chart showing the photos acquired in time and the number of detections for each district.
This report contains all the information to assess the accessibility of the city.
Yes, absolutely. And all of this can be achieved with SAS Via. Let's recap the process. In this case study, we have shown how it is possible to create a report of architectural barriers and accessibility of a city using images of public spaces.
Using computer vision models trained and deployed in SAS Via, we have trained and tested a functioning detection model which can identify ramps, steps, stairs, and grab bars. The model has been applied to a test set, and the result is displayed in a visual analytics dashboard. The report can be used to spot the exact location of barriers and can be the starting point for public administration to plan how to improve the accessibility of public spaces.
Indeed, we are looking forward to continuing developing and improving this model and using innovative technologies like SAS Via to create more inclusive space for everybody. That's all from us. Thank you for watching.